if you are having a lot of trouble with these graphs, I'm going to go through it again, just with some more deeper explanation, and then I'll do an example with something a little bit more complicated than the 4 basic types of motion that we've seen. So for your 3 main graphs, you have position versus time, velocity versus time, and acceleration versus time. The slope from this graph gives you velocity, and the slope from this graph gives you acceleration. So how do you figure out the slope for something that is not a line versus something that is a line? So this would be, let's see, decreasing speed in the positive, and then something else that is a line. You need to look at, for the position time graphs, tangent lines for every single point and see what the slope of those tangent lines are doing to then figure out what your velocity would be. To go from here to here is what we've already done. It's simple. This is a straight line. The slope is either positive, negative, or 0, so that determines whether your acceleration is positive, negative, or 0. It's here that you might have a little bit of trouble figuring out how to get to here. So I'm going to draw this nice and big, same exact graph on the next slide, this graph, to show you how we figure out what those slopes are telling us. So position time graph looked like this. And if I were to pick, let's say, random points on here, pretty evenly spaced, and then draw tangent lines for each of those points. From those tangent lines, so those are lines, you can get the slope of lines, you'll be able to determine the velocity. And you want to ask yourself 2 questions. So 2 questions. First, are those slopes increasing, decreasing, or constant? In other words, are all of these slopes here getting steeper? That would be increasing. Are they getting shallower as you go? That would be decreasing. Or are they all exactly the same? That would be constant. So first question, are those slopes increasing, decreasing, or constant? In this case, these slopes are getting shallower, so they're decreasing. The second question you need to ask yourself, are they positive, negative, or 0? All of these slopes are positive. So because these slopes are decreasing and positive, you know that your velocities have to start high and get smaller in the positive direction. So that would lead you to the velocity time graph, where you're going to start somewhere in the positive and you're going to end at 0. So if you have no numbers, you're just making this qualitative. Your slopes were a high positive. They ended up almost horizontal, so you're going down to 0. To make the acceleration time graph from this graph, your slope is a line. Your graph is a line, so the slope will be constant. All you need to determine is this constant slope positive, negative, or 0. Because this slope is negative and constant, when you make the acceleration time graph, you're going to have a constant negative slope. So that's how you get from one graph to the other by looking at their slopes and asking yourself those questions. 2 questions for the position time graph. Again, are the slopes of those tangent lines increasing, decreasing, or constant? And are they positive, negative, or zero? That tells you what the velocity will be. For the acceleration time graph, is the slope of the velocity positive, negative, or zero? We know it's constant because it's a line, so positive, negative, or zero will determine what this graph looks like. Let's look at one example where the graph's not going to look the same the whole time. So let's say we have a position time graph. I'm just going to draw the other ones right underneath for now. Oops, that should be a V. Running out of room. And let's say our graph looks like that. This should be straight, this is curved, and this is curved. I'm gonna draw lines down so that the other 2 graphs, it's easy to see where the 3 segments are. So looking at the first segment for the position time graph right here, is the slope increasing, decreasing, or constant? It's a straight line, so it's a constant slope. Positive, negative, or zero? It's positive. That means that my velocity needs to be, for that first segment, constant and positive. Constant velocity is just a horizontal line. The next part of the graph, if I look at the tangent lines, we're starting out shallow and we're getting steeper in the positive, which means our velocity is starting small positive and becoming a larger positive. Third segment, my velocities are starting out at a high negative and they're getting shallower. So we are starting out at a high negative and getting closer to zero. So my velocity time graph would look like that. Now we look at the acceleration. Acceleration for the first part is 0 because the slope of this line is 0. Slope of this line is positive and constant, so my acceleration is positive and constant. Slope of this line is positive and constant, and judging from this graph, this slope should be a little bit steeper, so my acceleration is positive and constant, but a little bit more than it was in the second segment. So you can see how this slope became this slope became this, the slope of these tangent lines became this, the slope of this straight line became this, and then the slope of these tangent lines became this, and the slope of this line became that. This is completely qualitative. It can be done quantitatively with numbers, but this is a very complex example of what a graph would look like with 3 different parts of the motion and how to get from position to velocity to acceleration.